Okay, welcome back. So I'd asked you to try and create a mapping rule for this particular transformed quadratic here, and it's a little bit trickier. I mean, before we had a nice little f out there in front to sort of help us really clearly see what was happening inside the function, what affected the x value, what was happening outside that, what happened what affected the y value. It's not exactly as clear here, but you have to remember here is once we know our parent function is y equals x squared, you have to think, okay, well, in the original parent function, our x was squared. So what's now squared instead of x? Well, it's this entire bracket, right? This entire bracket is now what's squared instead of just x. So everything inside there is what's happening to x. Everything outside there, this negative and this negative 2, for example, are what's happening to y. Okay, so for our mapping rule, to do x, we'll just look at what's inside here. So you start with x. The first thing that happens is a subtraction by 4. And then it's multiplication by negative a third, but it might be easy to write this as division by negative 3. Okay, so for the inverse, for our mapping rule, we do multiplication by negative 3, and then addition by 4. Okay, so for the y value, for the y part of the mapping rule, I multiply by negative 1 out here, and then I subtract 2, so my mapping rule should be negative 3x plus 4, and then negative y minus 2. Okay, so that's really all we need to graph, because once we have this, we know what y equals x squared looks like, or at least hopefully we do. I told you guys in the first day all of our parent functions need to be pretty committed to memory. So if you look at y equals x squared, there should be some key points that jump out at you, that being negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And you can see them on the graph right here. These are 5 pretty good key points to use. So now what we're going to do with each of those key points is now plug them into this mapping rule to get new image points. Okay, so again, negative 3 times negative 2 is 6, plus 4 is 10, and then negative 4 minus 2 is negative 6. We wind up with 10, negative 6. And you're going to repeat this process for all of the 5 key points you chose off the original function. Okay, and when all is said and done, hopefully what you have are points that should, when you graph them, be on this new parabola. So let's check this just to be sure. Okay, so when we plot those 5 points, you'll see that it seems like they fit a parabola right here, which is always the first thing that we're trying to check, see if it at least resembles the original shape. And then, just to confirm, we can see on Desmos that all those points pass through a new parabola. So again, using these 5 original points in the mapping rule, we're able to generate enough points here to create the equation of our transformed graph. Okay, and that's all we're doing with this. Okay, so what I'd like you guys to do now, there's a couple more here. Okay, there's one with a square root function, one with an absolute value function, before we get into doing the homework. So I'd like you to try doing these on your own first. So with each one, identify the parent function, try and create your mapping rule, and look for some key points you can use to generate a new graph. Okay, so try those on your own and push play and ready to go through them together. Okay, so for this one, hopefully you recognize the parent function is going to be a square root function. And a square root function will have these key points. Now, there are some other points you could see from the table of values you did back on the first day, but you want to choose nice points, right? If you choose x equals 2, for example, the y value is not going to be very nice because it's the square root of 2, which isn't a very nice value. So that's not very, very helpful to use to try and get a nice accurate point. So use nice key points. So if you're ever stuck, remember that you can always just do a table of values, but just make sure you pick points that turn out nicely to get accurate results in your graph. So once you have your parent function, notice here, okay, well we had the square root of x, so instead of the square root of x of our transform function, the square root of 9x minus 3. So it's the 9x minus 3 that we need to look at to create our mapping rule for x. So we have x multiplied by 9 before it gets subtracted by 3. So for our mapping rule, we add 3 first and then divide by 9. Okay, and for y, it's simply 2y minus 4. So these are 4 pretty nice key points to use, 0, 0, 1, 1, 4, 2, and 9, 3. We plug them into our mapping rule to get 4 image points, and in theory, if you could make a nice accurate graph with these points, you would have a pretty good idea of what the shape of this guy would look like. Okay, so you haven't done so yet, pause it and do the absolute value function right here, but if you have given it a try, here's how it works. So again, your parent function here is the absolute value function. So instead of absolute value of x, it's absolute value of half x plus 4. So we have x, which is divided by 2 before 4 is added to it. So for the inverse, we subtract 4 and then multiply by 2. For the y part of the mapping rule, it's simply negative 3y plus 6. Okay, so again, note here that x gets subtracted by 4 first before it gets multiplied by 2. If you want to, you can simplify this mapping rule, just get to 2x minus 8, but that's not necessary. That's entirely up to you if you want to do that. Okay, as for key points, if you don't remember what absolute value looks like, really it looks like a v. So one way to think about it is it really is just the line y equals x, but everything that's below the x-axis has been reflected to be above it. Okay, so some key points that are on there. Again, if you're ever completely stuck, simply do a table of values. But when x equals negative 2, the absolute value of negative 2 is 2, and so on and so forth. So you get these 5 key points. You plug them into your mapping rule, get 5 image points, and then you have enough to create your graph. Okay, so that was a long lesson, but again, transformations are going to show up over and over and over again, so you need to have the idea of mapping rules, transformations, and equations that transform functions, being able to move almost seamlessly between the 3 representations if you want to be successful in this course, and even more so in 4U as well. So do the practice now. Go through the routine of making sure you create that input-output diagram for X to get your mapping rule correct, because again, this is a pretty essential skill for the course. Okay, there's some questions there in the textbook to try, just to reinforce how everything is going, and then we're going to do more transformations in the next lesson.